Yeah, welcome to the fifth and final lesson in the circles topic at Higher Maths. What we're going to look at today is intersecting circles and the conditions for when and how they intersect. That's exactly what it is there. Find the number of point intersections between two circles. Okay, what I'm going to do is actually I'm going to go to PowerPoint here. Now you don't need to copy any of this down. I'll get you a note once we go back to the other program. But we're going to look at just a couple of situations here. Firstly, the thing to note is that the shortest distance between circles is along the line that comes from centre to centre. And what we're going to do to compare the points of intersection here is look at all the different situations comparing the two radii or each radius to the distance between the centres. Now here, obviously we have two circles that are not intersecting at all. Now the important thing here is see when you add together the distance that you get when you get two radiuses, or the two radii, the radius of each circle. If you add those together, comparatively between that distance AB, there is more distance between A and B than the two radiuses can cover. So the RA plus RB, both radiuses, is less than the distance between A and B. So if you find each radius, add them together, and it's less than the overall distance between the two centres, there has to be a spare bit in the middle, and therefore they do not intersect at all. Okay, and that's the first condition we're looking for. The second, okay, moving. Okay, that's just everything I've just said there. If we move the circle in though, okay, and move that so they touch in exactly one place, you notice there that if you add each radius together, then it's going to be exactly the same distance as the distance between the centres. So if you add the two radii together and it's the same as the distance between the centres, then they touch externally at one place. The circles will touch externally at one place. Okay, if we do go even further and we overlap them, then the two radii, adding them together, okay, moving that back out here, is going to give you a bigger distance than what you cover between A and B. Okay, because the radii, you can separate them out, you can move them apart. It'll make a bigger difference than there, a bigger distance than the distance between the centres. So if you add the radii together and you get more of you get a larger distance than the distance between the centres, then they have to overlap and cut at two places, intersect at two places there. And the last situation we're going to look at is when they move closer than that, when they touch internally. And I hope you can see there that the distance between the centres is just the difference between the radii. So if you do RA and take away the smaller radii or the smaller radius, then that will equal the distance between the centres, because that difference is what the radius, that difference there is the difference between the two radiuses. Okay, so if that is the case, then the circles are said to touch internally, okay, because it's touching them inside that circle. Now that's your four options. Now a lot of the time is just kind of thinking about it and figuring it out, and that's what you may have to do if you get this in the exam. Okay, I'm not going to do that example. I'm going to go back to my notes now. Okay, copy that down. Pause it now, copy that down. Cheers. Okay, when circles overlap, and R1 plus R2 is greater than the distances between the centres. When circles touch externally, and this is by far and away the most common one, to be honest, then the distance between the radiuses is the same. Sorry, the sum of the two radiuses is the same as the distance between the centres. If they touch internally, then the larger radius subtract the smaller radius will be, in fact I don't know why I've used A and B. I'm just going to change that to 1 and 2. Okay. So the difference between the two radiuses will be the same as the distance between the centres, and if they don't intersect at all, then the sum of the radii will be less than the distance between the centres. Okay, so pause it there and get those two copied. Pause it there and get those two copied. Okay, now that's your 4 situations. This one here is by far and away the most common. Now we're just going to do an example just with this. Okay, so circle P has the equation there, circle Q has centre and radius. Show that these circles touch. Okay, firstly for circle P, we want the centre and we want the radius. Now the centre, G is going to be -4 and F is going to be -10. So the centre for P is just going to be 410. The radius is the square root of -4 squared plus 10 squared and -10 squared that. Subtract 9. That's 116. Subtract 9, which is root of 107. Hang on, sorry, I'm just realising I made a mistake. F is not that at all, which changes all of this. Give me 2 seconds, I'll come. Really sorry about that. I made a mistake up here. I forgot to half the value in front of y, so f is actually equals to -5, which makes your centre 4, 5. And when you put that into your radius formula, it gives you a radius of root 32, which is really 4 root 2. Okay, now because you've got the centre of Q is -2, -1, and the centre of P is 4, 5. To calculate your distance between the centres, Q and P, -2 to 4 is 6, -1 to 5 is 6. So QP is root of 6 squared plus 6 squared, so root of 6 squared plus 6 squared, which is the square root of 72, which is 6 root 2. So RP plus RQ is equal, RP is 4 root 2, RQ from your equation is 2 root 2, which is equal to 6 root 2, which is the distance between the centres, QP. And after you've proven that, after you know that, after you compared the sum of the radii and the distance between the centres, you can say since RP plus RQ is equal to QP, circles touch externally. Okay, and it's all about comparing the sum of your two radiuses, or sum of your radii, to the distance between the centres. Okay, apologies for the mistake there, and also the length of the video, but hopefully that kind of covers everything. Give me or your teacher a shout if you need a hand in, and that's your circle topic done. Cheers.